Hello students, myself Alpesh from Electronics and Communication Department. Welcome you all in LJP EC-A. Today in Antenna and Wave Propagation subject, we will learn about dipole and half-wave dipole antenna, which are very basic antenna used in variety of applications. So let's see the content of today's video. First, that is what is dipole, its construction, half-wave dipole, its construction, working, advantages and disadvantages, and at last we will see some applications of the dipole antenna. So let's see the first antenna, that is the dipole antenna. The radiation energy when done through such a bent wire or a conducting wire, the end of such a transmission line is termed as dipole or dipole antenna. From the name we can say the di means two, so the antenna which having a two pole, it is known as the dipole antenna. The reactance of the input impedance is a function of radius and the length of the dipole. The smaller the radius, larger the amplitude of the reactance. It is proportional to the wavelength also, as lambda is proportional to 1 upon f. Hence, the length and the radius of the dipole should be taken into consideration, so that at the time of designing we have to consider the material, radius and the length of the dipole. Normally the input impedance is around 72 ohm for the dipole antenna. Here we have a figure of the dipole antenna. We have taken one conducting material or a conducting wire and divided into a center. At the center we applied a feed line as the AC input, and both the end of the antenna are open. So we can say that this is the dipole antenna. Now the current is minimum at the end of dipole and maximum at the center where the feed is applied. The voltage follows a different pattern as per the current, and it is low at the middle where the feed is applied and high at the end. The types of wire antenna includes half-wave dipole, half-wave folded dipole, full-wave dipole and a short dipole. So this is the dipole antenna. Now before we see the half-wave dipole antenna, there is a MCQ based exam at the end of this video, so make sure to attend this exam. Now the second antenna is half-wave dipole antenna. As the name said, half wave. Wave means the wavelength. So the dipole which having a half wavelength, it means the length of the dipole is half of its wavelength. It is known as the half wave dipole antenna. So the dipole antenna is cut for effective radiation, and the length of the total wire which is being used as a dipole is equal to half of the wavelength. It means length of the dipole is equal to lambda by 2. Such an antenna is called as half-wave dipole antenna. This is the most widely used antenna because of its advantages. It is also known as the Hertz antenna. Now, what is the frequency range of the half-wave dipole antenna? The range of frequency in which half-wave dipole operates is around 3 kHz to 300 GHz. This is mostly used in radio receivers. So it having much larger bandwidth for the operation. Now let's see the construction and working of the half-wave dipole antenna. It is a normal dipole antenna where the frequency of its operation is half of its wavelength. Hence, it is called a half-wave dipole antenna. The edge of the dipole has maximum voltage This voltage is alternating in nature as we applied a alternating current at the feed line. Now, at the positive peak of the voltage, the electron tends to move in one direction, and at the negative peak, the electron move in other direction. This can be explained from the figure. So, figure 1 is here. Here we have a dipole antenna. So, the length of the dipole is exactly half of its wavelength. So, it is known as the half-wave dipole antenna. So, now when we applied a positive half cycle at the half-wave dipole antenna, so what will be occur or what will happen in this dipole? So, when we see inside it, the charge is induced in the positive half cycle. Now, the electron moves towards the charge. Now, what happens if we give the negative cycle? So, here the figure is shown, the negative cycle is applied. Now, the electron tends to move away from the dipole. So, when we applied a positive half cycle, the electron move towards the center, and we applied negative cycle, electron move away from the center. Now, the third figure is shows again we applied the next positive half cycle, hence the electron again move towards the charge. Now, the cumulative effect of this produces a varying field effect which gets radiated in the same pattern produced on it. Hence, the output would be an effective radiation following the cycles of the output voltage pattern, in which voltage is in red color and current is in blue color. So, this figure shows the again radiation pattern in the half wave dipole as we applied a AC input in it. So, it is the again 3D of the half wave dipole antenna. Now, let's see the radiation pattern of the half wave dipole antenna. So, here the radiation pattern is of the half wave dipole is omnidirectional and it is in the H plane. It is desirable for many applications such as mobile communication, radio receivers, etc. So here we have two figures of the half wave dipole antenna which are the radiation pattern of the half wave dipole. So first figure is the according to the H plane and the second figure is according to the V plane. Now, the radius of the dipole does not affect its input impedance in this half wave dipole because the length of this dipole is half of the wavelength and it is the first resonant length, and an antenna works effectively at its resonant frequency which occurs at its resonant length. Now let's see what are the advantages of the antenna. First, that is the input impedance is not sensitive, matches well with the transmission line and impedance, has reasonable length, and last one is the length of the antenna matches with the size and the directivity. Now, what are the disadvantages? The first, not much effective due to the single element. Yes, this is the single element of the dipole, so it is not effectively work. It work better only with the combination. Means when we combine some another antenna with the dipole or a half wave dipole, it works more effectively. Now let's see what are the applications. It is used in radio receivers, television receivers, or when employed with other used for a wide variety of applications. So here we have some pictures of the application where the half wave dipole or dipole antenna are used. Now at the last, as we said, we have an assignment and quiz for you. First, that is assignment. First question, explain the dipole antenna. Second, what is half wave dipole? Third, describe the construction and working of the half-wave dipole. And the fourth, that is last, list the advantages, disadvantages and applications of the half-wave dipole antenna. Or you can attempt the quiz based on this video, either scanning by QR code or click on the link given in the description of this video. Total 20 questions with 50% passing marks. So thank you students for watching this video. See you in the next session of antenna and wave propagation.
If you like this video, please subscribe and like our YouTube channel LJPEC-ELE, and don't forget to click on the bell icon to get latest video update fast.